kind of, sort of, maybe. And psych, did you talk about that in psych? No.
I'm sorry?
Did you talk about standard deviation, normal distribution in psych?
Oh, yes, so lost.
Yeah.
I would go to Mr. Peyton and help actually last year.
Okay. The mean, do you all know what mean is?
Mean?
Yeah, what's the mean of some data? Not are you mean. What is the mean? Yeah. Add them all, divide by the total. The mean is another word for average. Mean is our average. So it tells you what the center looks like. But that can look skewed. You know, if I have the center and, like, if I look at the average of test scores, let's say the average is 50. Well, that means somebody could have gotten a 0 and somebody got it 100. Or it could have meant the scores range from 40 to 60. Okay? Those are two totally different data sets. That's what standard deviation helps us decide. Okay? So, like let's look at set A, set B. If you added them all up, your average would be the same for both of them. But if this were, if we're looking at how close the data is, which one's closer? Set A. Okay, so same average, but way different data, right? If you're looking how far apart they are. So standard deviation describes how spread out the data is. So to help us determine, is the data close together? If we're looking at averages of test scores, everyone around each other, or is it way spread out? If you're looking at average height, is everybody about the same height, or somebody way taller, way shorter? Okay, so standard deviation tells us how spread out the data is. A deviation at the bottom is one step or one deviation away from the mean. Mean again meaning our average. Okay. If we look at this first example, it says you can describe the spread of a set of data values by counting the number of standard deviations from the mean that it takes to include some or all of our values. Some notation. This X bar thing, it's literally an X with a bar on top of it, is how we write our mean. Okay, that's what mean stands for. Okay, this is how we write mean. This little curly O thing is what represents standard deviation. Okay, those are the symbols that we use to describe mean and standard deviation. Mathematicians are really lazy, and so they just made shortcuts for everything. I don't know if you've ever noticed that.
Yes.
No? Yes?
Yeah.
Scientists are kind of lazy too, though, so it's okay. Okay, so if you look, obviously we have our average in the middle. If I go 1 standard deviation away or 2, I can go positive or negative. Just like heights, I can be shorter than the average, taller than the average, and I can be 1 deviation away or 2. Okay. It says the data set 5, 9, 15, 24, 25, 27 has a mean of 17.5 and a standard deviation of about 8.5. I want to know within how many standard deviations of the mean do all the values fall. Okay, so the first thing we're going to do is kind of draw that top diagram. In the middle, we have our mean. And it says the mean of our data is what?
17.5.
17.5. Okay, so here in the middle is 17.5. Then it says the standard deviation is 8.5. So if I move 1 standard deviation to the right, what value am I at? So if I go to the right, 8.5, what value am I at? 26. Okay. If I go one deviation to the left, I'm at what? 9. Okay. What if I go from my 26, the first deviation, what if I go another 8.5? What value am I at then? 34.5. And what if I go one more to the left? 0.5. Okay. So we have a little diagram set. I want to know within how many standard deviations of the mean do all my values fall. Okay? So let's start plugging in our values. The first value we have is 5. 5 is between 0.5 and 9, right? So in between these two data values is our 5. Okay. 9 falls exactly on one of our breaking points. So we just leave it at 9. Put it right here. Where does 15 go?
In between 9 and 17.
In between 9 and 17.5. What about 24? Where's 25 go? Same place. And 27 goes on our last one. So within how many standard deviations am I? Here's a total of 1 standard deviation, right? Because I'm 1 to the right, 1 to the left. I'm a total of 2. 2 to the right, 2 to the left includes all my values. So 2 standard deviations away. Okay. Questions on how we set up our diagram? Questions on how we place values?
So if we have like the 9, we don't have to write it.
No.
So it's
I mean, if you want, you can put it like right here. But if it, so like let's say we didn't have this 5 or the 27, since 9 is on the value, you would say that we're just 1 standard deviation away. Does that make sense? So if it's right on that line, include it in the first one.
Wait, why is it 2 and not 4?
Because, so here's our middle, and if I go 1 standard deviation, that's 1 to the right and 1 to the left. So this whole thing is just 1 standard deviation away. Does that make sense? Okay, other questions? Okay. This one, we're not going to calculate standard deviation yet. We're going to do that tomorrow. So I'm just going to give you the values of this. First, we'll read through them. It says we're painting your house and are trying to figure out if paint all or true colors is the better choice. You have data that tells how many months the paint lasted before shipping from 6 different customers for each brand. The months are listed below. So our paint all, we have 15, 65, 55, 35, 45, 25. True colors close together, right? So which one do you think has a closer standard deviation? True colors that would have a smaller standard deviation. Okay, you guys all have a calculator? We're gonna practice finding mean. Okay, mean the average. Molly, how'd you say we calculate mean?
Add up all your options and you add it back to
Right. Add up our numbers, 15, 65, 55, 35, 45, 25. If I add them all up, what do I get? 240. And then we divide by how many numbers we have. 1, 2, 3, 4, 5, 6. And I get 40. So my average is 40. What about true colors? What's my average there?
240.
40. Like I said, I'll give you standard deviation. We're going to learn tomorrow how to calculate it. Standard deviation for paint doll 17.1. And like we guessed, standard deviation for true colors is smaller. Okay, 6.5. So based on that information, our average is the same, but which one would you choose to buy? The paint doll?
True colors.
Probably true colors because it's more representative of your average. I mean, if you gamble with the paint doll, you might get one that's 65 months, but you might also get one that's 15, where you're almost guaranteed to be at least 30 with true colors. Okay? So what we say, true colors, because it is less spread out. Smaller deviation. All those.
Why did you get 6.5 and 17.1?
I calculated it, which you will learn to do tomorrow. Right now, we can't. Because we'd be way over ahead. We gotta get the basics down first. Okay, normal distribution. Fancy definition, data that vary randomly from the mean in a bell shape curve. Data that vary randomly from the mean in a bell shape curve.
I don't understand.
We're going to draw a picture and that'll help us understand. What a normal distribution looks like is something kind of like that, where right in the middle is your mean, your average. Okay? You ever heard of like, you can normalize test scores? So take the average and then however far away you are from the average is what your grade is. That's a rough one. If you ever have a college professor that says grades are based on a normal distribution or normalized, run. It's horrible.
Well,
Because if
but isn't the average like closer to you than what? I feel like that would be easier.
like if you got a 74 on a test and the average was a 78 and they're all close together, instead of getting a 74, you're getting way down here, which is like a. So if you're lower,
But would you just get like a 96 or 96 because it's wrong?
no, but if all your data is together, so like let's say the average is 78 and everyone but you got between like a 76 and an 80,
Yes.
then yeah, it's no point. It can benefit you, but okay. So bell shaped. I tried to make it even. It probably doesn't look even. You have the same amount of data from the left of your mean as you do the right. So this is 50%. 50% of the data is lower. 50% of the data is higher than whatever your average is. Okay. I'm gonna draw this one bigger because we gotta put numbers in it. Okay, so the 68, 95, 99.7 rule tells you how much data is in far away from the standard deviation. Okay, so we still have our average. Our average is in the middle. Okay, if I go one standard deviation away, so one to the left and one to the right, I try to make them the same distance. obviously as we saw in that diagram, it would be the same distance left and right. 68% of your data lies within 1 standard deviation away. Okay, so that means if you're 1 standard deviation lower, has 34%, 1 standard deviation higher has 34%. So if you are 1 standard deviation away from the mean, you lie within 68% of the data. Okay, so you're not too far away. Most numbers lie, obviously more than half, lie within 1 distribution away from the mean. Or deviation, I'm sorry. If we move 1 more deviation, this is where 95% of the data lie. So almost all of your data lies within 2 deviations. 1, 2. Okay, so out here, this includes 13.5%, and this one includes 13.5%. Okay, so 1 standard deviation away, we're in 68% of our data. 2 standard deviations, 95%. 3 standard deviations, we are in 99.7% of our data. Okay, so this is 2.95, and this one is 2.95. Okay, so 68 is 1 standard deviation away, 95 is 2 standard deviations away, and 99.7 is 3 standard deviations away. So 99.7% of our data lies within 3 standard deviations in a normal curve, normal distribution. Okay. We all have this diagram copied?
Yeah.
Okay. Don't worry about the vocab on the bottom. Okay. So example 1 says, suppose data are normally distributed with a mean of 100 and a standard deviation of 20. Between what 2 values will approximately 68% of the data fall? Well, 68% is how many standard deviations? 1. Okay, so I have my average is 100. I only need to go 1 standard deviation away. So what's 1 standard deviation to the right? I'd be at what number? 120. If I move 1 standard deviation to the left, I'm at what? 80. Okay, so between what 2 values does 68% of the data fall? 80 and 120. Okay, does that make sense? I just have to take my mean, subtract, and add whatever the standard deviation is, and that's where 68% of my data is. Number 2 says the sum of all the deviations about the mean of a set of data is always going to be equal to, what do you guys think? If I added all the ways I vary, if this is half, and I add up all of these positives, all these negatives, what do you think is going to happen to them? They cancel out, yeah. So when I add them all, it's going to cancel out to 0. Because 50% of the data is this way, 50% is this way, so 50 is positive, 50 is negative. Since we're right in the middle, they're going to cancel out. Okay, next one. Suppose data are normally distributed with a mean of 50, standard deviation of 10. Between what two values will approximately 95% of the data fall? Well, 95% is how many standard deviations away? 2. So we'll take our mean, put it in the middle. My standard deviation is 10. So if I move 1 to the right, what am I at? 60. 1 to the left puts me at 40. So that's 1 deviation, but you said I need 2. So let's go 10 more to the right, which puts me at 70. 10 more to the left puts me at 30. So between what two numbers will 95% of the data fall? B. 30 and 70. Okay. Questions there? Okay, it says data is normally distributed. What percent should lie within 3 standard deviations? Which one? D. I can't hear if you said B or D, sorry. Oops, sorry. Wrong one. My bad. Okay, I have a mean of 75, standard deviation of 15. What proportion will lie between 45 and 105? What percent? Okay, so my middle value, my mean is 75. My standard deviation is 15. So what's my right value if I go 1 standard deviation? 90. What if I go 1 standard deviation to the left? 60. Am I between 45 and 105 yet? Nope. So let's try it again. If I add 15 to 90, 105, 45, I am there. So how many standard deviations away? If this is my middle, I am 2 standard deviations. Which one? 95. 2 is 95%. Okay, try number 8 on your own, and we'll compare answers. What's that? Yes. Anybody have answers for me? B. B? We all in agreement?
Yeah.
68%? Awesome. Okay, last page. In the United States, cola can normally be bought in 8-ounce cans. A survey was conducted where 250 cans of cola were taken from a manufacturing warehouse and the volumes were measured. It was found that the mean volume was 7.5 ounces and the standard deviation was 0.1 ounce. Draw a normal distribution curve to represent this data. Pause. Normal distribution curve. I'm getting better, I swear. What goes in the middle?
7.5.
7.5. I want to know what values 68% of the data can be found between. 68, how many deviations away? 1. So what values do I need in my drawing? What are my values? If I move 7.4 and what? And 7.6, good. Put those in our blank up here. 7.4 and 7.6. 95% of the volumes can be found between what and what?
7.3.
7.3, 7.7. And the last one, 99.7% of the data. 7.2, 7.8. Okay, and the last example. The mean height of the fourth graders in a local elementary school are found to be 4'8" or 56 inches. Standard deviation was found to be 5 inches. Draw a normal distribution curve to represent this data. Let's just make the bars. Are the bars okay? We just do the bars. Okay, so my mean is 56. If I'm one standard deviation away, 68% of my data is between what two numbers? What numbers represent 95% of my data? And what else, Gabe? 66. And 99.7%? 41 and 71. Okay. Questions? What do we think? Not too bad?